Welcome to Let's Get to the Marks. This is a request from Abigail Thomas, one of the viewers. So we're going through AQA A-Level Chemistry, Paper 1, Question 10 from 2018. And it's basically about the amount of substance and how you find X, the integer, in a hydrated compound. So a student added 67 milligrams of hydrated sodium carbonate to 200 centimeter cubed of 0.250 mole per decimeter hydrochloric acid in a beaker and stirred the mixture. After the reaction was complete, the resulting solution was transferred to a volumetric flask made up to 250 centimeter cube with deionized water and mixed thoroughly. Several 25 centimeter cube portions of the resulting solution were titrated with 0.150 mole per decimeter aqueous sodium hydroxide. The mean titer was 26.6 of aqueous sodium hydroxide. Calculate the value of X in Na2CO3.X H2O. Show you're working. Give your answer as an integer, 7 marks. Let's get to it. So here we have our hydrated sodium carbonate, and essentially you need to find out X. So once you know the core principles of this, you'll be able to handle all of these questions. You look at the sodium carbonate, the bit before the dot, find out the moles of that. Then look at the water, the H2O, find out the moles of that. Then divide the moles of the water by the moles of the substance before the dot, and you will have X. You round it to the nearest whole number because it has to be an integer. There's a certain amount of water molecules in these hydrated substances that bond around. You can't have 5.5 water molecules. So normally you would heat this hydrated substance to a constant weight. You'd evaporate all the water and then subtract that mass. You'd find out the mass after it reaches a constant weight, and you'd subtract that and you would work out the mass of water and then do mass over MR, which is 18 for water, and you get the moles. That's dead easy. But of course, they did it a really difficult way here. Instead of evaporating the water, they said, well, we have a carbonate. Let's react it with an acid. So the carbonate was reacted with an acid. And the acid in question is hydrochloric acid. And all we need to do is recall from GCSE that acid plus carbonate makes carbon dioxide, water, and a salt. And then we need to write that equation out and work out the ratio between the carbonate and the acid. So we have Na2CO3 plus HCl. You should know this from GCSE, how to do these. So it goes NaCl, which is your sodium chloride, and then we're going to make carbon dioxide and water, or water and carbon dioxide. The order doesn't matter. We now need to balance it up. Well, I've got 2 hydrogens on the water, so I'm going to need a 2 in front of the HCl, and I've got 2 sodiums in the carbonate, so I'm going to need a 2 in front of the NaCl. And the main takeaway from this is that my ratio of reaction between the carbonate and the hydrochloric acid is 1 to 2. I'm going to need 2 lots of hydrochloric acid, or moles of hydrochloric acid, for every mole of sodium carbonate. Now, we were also told in the question that we had 627 milligrams of the hydrated carbonate. We need to divide by 1,000, and that gives us 0.627 grams of the whole thing. Now, in order to work out how many moles of sodium carbonate we've got, we need to use excess hydrochloric acid. That's why I've written excess there. And so you kind of need to work out the original moles of hydrochloric acid, and we get the information in the stem, which we'll look at in a second. Then we need to work out the leftover moles of hydrochloric acid, which is how much we react in the second equation, which is our kind of back titration. And then we find out how many are reacted. So let's find out how much hydrochloric acid they added originally, and it was 0.250 mole per decimeter. That's the concentration, and we've got a volume of 200 centimeter cubed. So let's find out the original moles of hydrochloric acid added to the sodium carbonate in this first reaction. And in order to do that, we need to do 200 over 1,000, which is the volume, and multiply it by 0.250, which is the concentration, and C times V gives us N. So 200 over 1,000 times 0.250 gives us 0.05 moles of hydrochloric acid. We know the original moles of HCl that reacted with the sodium carbonate was 0.05. Now we know that some of it was left over because it was excess, and they re-reacted that in a titration with sodium hydroxide. And they took a tenth, 25 out of 250 centimeters of the hydrochloric acid that was left over, and reacted it and they found that it was neutralized with 26.6 centimeter cubed of 0.150 moles of sodium hydroxide. So what did they actually do? Well, they took the products of the first reaction. That's the sodium chloride, the water, and the carbon dioxide. And of course, they stuck all of that into a flask and made it up to a set volume. Okay, now that contained the leftover HCl. The other products aren't going to react with sodium hydroxide. So they've now done a neutralization, a titration with sodium hydroxide. Now they've reacted it, and of course it forms salt and water. You know that from GCSE. Acid and alkali make salt and water. And we can see from this balanced equation here that it's 1 to 1. So our leftover acid was reacted with that sodium hydroxide in a 1 to 1. So now we do moles over concentration times volume. We know the sodium hydroxide had a 0.150 concentration from the stem of the question we just looked at. And the volume is 26.60 centimeter cubed. We divide by 1,000 to turn it into the correct decimeter volume. And we multiply C and V to get the moles, which is 3.99 times 10 to the minus 3. Now, that is a 1 to 1 reaction, which means we have 3.99 times 10 to the minus 3 moles of hydrochloric acid too. However, that is in 25 centimeter cube. Remember, we took the 250 and we only titrated 25 centimeters. There was 250 in the flask and we only titrated 25. So to find out how many leftover HCl was originally in that flask, left over from the first reaction, we've got to multiply by 10. And if you do 3.99 times 10 to the minus 3 times 10, we'll find out that in the original 250 centimeter flask, we had 0.099 moles of hydrochloric acid. And that was the leftover moles. So how many were used in the original reaction with sodium carbonate? Well, we take the starting moles of HCl, which was 0.05. We take away the leftover moles, 0.0399. And we find out that the amount of moles that reacted with the sodium carbonate was 0.0101. Now we need to divide that by 2, because remember in the original equation we worked out the ratio of HCl to sodium carbonate was 2 to 1. So we've now found out that we have 5.05 times 10 to the minus 3 moles of sodium carbonate. That's brilliant, but we need our moles of water to finish this equation. And in order to do that, we need to find the mass of sodium carbonate. We can do that by multiplying its MR of 106 by its moles to find the original mass. Why do we need to find its mass when we've already got its moles? Because we need to find the mass of water. So we're going to take 0.627, which is the mass of the sodium carbonate and the water, and we're going to subtract it from the mass of our sodium carbonate, which is 0.5353 grams. And that's going to give us our mass of water. So we go 0.627 minus 0.53 grams, and that is going to give us something along the lines of 0.0917 grams of H2O is what we have. Long way about it, I know. Stick with it. We now need to work out the moles of water. Do you know the MR of water? You've got 2 hydrogens and an oxygen. It's 18. So you divide your mass of water, 0.0917, by 18. We now finally have our moles of water. We have 5.09 times 10 to the minus 3 moles of water. Pretty similar, right, to the moles of sodium carbonate, 5.05 times 10 to the minus 3. We divide our moles of water, 5.09 times 10 to the minus 3, by 5.05 times 10 to the minus 3. Now, you're not going to get exactly 1, but they've told us what is the integer x. They've told us it's a whole number. So the answer must be 1. And there you go. Share with other students, like, subscribe. If you have any questions you'd like me to put a walkthrough to, just hit me up in the comments. All right, let's get to the marks.
You're still here? It's over.